Hello world, welcome to Season 1, Episode 2 of Graphs and Datasets Explained. In this series of tutorials, we try to learn and help the global community read and interpret different types of graphs. Today's graph can be found on the internet on a popular website called reddit.com. The graph is categorized under a category ID, Data is Ugly. Data, spelled D-A-T-A, is spelled I-S, ugly, spelled U-G-L-Y. Some quick statistics to note: Data is Ugly is estimated to currently contain 148,000 members, and 14 are online. That's about 1% of members that are currently online, and 99% of all members are currently offline. Let's switch gears and start today's analysis. First, pause this video and try to read and interpret the graph you see on the screen. Spend at least 5 minutes and less than 15 minutes reading. If it helps, have a writing tool and blank sheet of paper ready to write or draw any thoughts. All right, it's your move. All right, let's resume. First, let's read the title of the graph. Titles are usually, but not always, positioned at the top, and it describes the graph's contents positioned underneath. So looking at this graph in this case, let's just find the top, which would be this area, and this reads percent female security officers by year. Okay, step 1 complete. Step 2, let's look at this variable on this horizontal axis. Year, okay. And looks like the leftmost year is 2010, and the rightmost year is 2019. Let's check the scale. So let's see, 2019 minus 2018 is 1 year. 2018 minus 2017 is 1 year. 2017 minus 2016 is 1 year. 2016 minus 2015 is 1 year. 2015 minus 2014 is 1 year. 2014 minus 2013 is 1 year. 2013 minus 2012 is also 1 year. 2012 subtract 2011 is 1 year. And lastly, 2011 minus 2010 is 1 year. So this is a good sign because the difference between each year is 1, which means that our scale is uniform and consistent. Next, let's look at the y-axis. Okay, I'm already starting to see a lot of problems with this graphs, and maybe you watching also see many problems. So let's go into depth further on these problems. So the variable is percent female. Okay, no problems with that. And it's like this reads 28%, and then 29%, and then 29%, and then 29%. Okay, that doesn't make sense. this is completely false because we're at two different points, or in this case, three different points on the y-axis, or sorry, vertical axis, this vertical axis, and they're all equal even though they're positioned they're completely at different positions on this graph. So that's very misleading and confusing, and right away that just breaks the trust between me and this graph, and we can't. It would be wrong and false to try to draw any hypothesis or try to draw any valid conclusions from this graph because it's unreliable in that sense. So let's actually look at this data point. So if we zoom out a bit, we see this graph has kind of like a zigzag pattern, right? If we see this blue dashed line, and from 2010 to 2011, the function is increasing, and then it's decreasing, and then it's decreasing, and then it's increasing, and then it's decreasing, and then it's increasing. You get the point. Let's use one of these data points to determine whether or not the scale is accurate or matches with like what this data is actually presenting. So earlier I reviewed this data point, 28.5%. 28.5% is the midpoint between 28% and 29%. And we can check this with basic arithmetic. So 28.5% minus 28% is a difference of 0.5%, and 29% minus 28.5% is 0.5%. And so in both cases, the differences are 0.5%. So then by definition, 28.5% is the midpoint and halfway between 28% and 29%. But this graph contradicts this same idea. If we assume 20, oh, we know, but if we were to assume that 28.5% was the midpoint between 28% and 29%, it would be logical of us to place 28.5% at a point between 28% and 29% so that that point is equally distant from 29% and 28%. However, in this case, this is false. 28.5%, this point, is positioned very close to 28%. And its position, this blue dot, is positioned closer to 28% and 29%, which contradicts our requirement for this data point to be the midpoint that we just previously proved. Let's do another example. So this point here, this blue dot here, so year 2013 is 28.4%. And there's a problem here. The problem is that 28.4%, this blue dot, is positioned below 28%, but 28.4% is this graph communicates that 28.4% is less than 28%. But this is absolutely false because 28.4% is greater than 28%. Okay, let's look at one more example. Example number 3. Actually, I just realized. So we have 3 areas where this is 20, where this graph's vertical scale says 29%, and then 4 of these tick marks all say 30%, which is another red flag and another reason to distrust this data